Hi everyone, this is Mrs. Snowbeck. Today we will cover Unit 6, Lesson 2. It'll be more about vectors. And by the end, we hope you can say I can add and subtract vectors, I can multiply a vector by a constant, I can find the magnitude of a vector, and I can find the horizontal and vertical components of a vector. Let's do a quick recap of section 6.1. Remember, a vector is a line segment that has magnitude and direction, and the way that you represent it is actually with a ray. It's a segment with an arrow on one end. It has an initial point where it starts from. In this case, A is the initial point, and then you can see the vector goes off towards B, and B would be called the terminal point. I could call the length of this vector u, for instance, or I could say u is vector AB, and I could put an AB with a little arrow above it to represent this vector as well. In the previous section, you also learned a few things about vectors, like how to add them, subtract them, or multiply by a scalar. Here you can see an example of addition of vectors. So we had two vectors. We had vector u and vector v. And let's just say here's vector u, here's vector v. Well, what happened is we get what's known as a resultant vector, AC. So resultant vector started at A and ended at C. That's the result of adding u plus v. Recall, you can also subtract vectors. So let's say we have vector u, which is right here, and we have vector v, which is right up here. But instead of adding them, this would be the resultant vector up top here if we added them, but instead of adding them, what if we subtracted them? All right, so I'm going to erase that. What you have to do, remember, to subtract, if I want to subtract v, is I just flip that vector around and have it go in the opposite direction. So it's kind of like a 180-degree flip. So instead of the vector heading off up towards the upper right, if I need negative v instead, I'm going to head down towards the bottom left. I'm going to have a 180-degree angle difference in their direction if I subtract. So this would be the resultant vector right here of u minus v, because v went in the negative direction. Vectors are often represented in a coordinate plane. So let's say I had vector v. I'm just going to draw in a random vector. I'll call this vector v. This vector has an initial point down here. We can call that P. And it has a terminal point up here. We can call that Q. At the terminal point, you could put a coordinate there, but oftentimes when using vectors, instead of calling it a coordinate, they call it a component. And the component has an A value and a B value, and it's basically the horizontal component and the vertical component. So the horizontal component would be over A, the vertical component would be up B in this case, and they would be perpendicular to each other. And something that's pretty cool about this is I could use that horizontal component and vertical component to find the magnitude of the vector. Think about the Pythagorean theorem. If I wanted to figure out how long vector v was, I could do a squared plus b squared equals v squared. And if I was going to solve this, I would take the square root of both sides, and I would get the square root of a squared plus b squared equals the vector. And because we're dealing with lengths, you're never going to have a negative distance. And so in this case, you can see our little formula here for the magnitude of a vector. It's the absolute value of v equals the square root of a squared plus b squared. Basically the Pythagorean theorem. One other thing I wanted to point out, in my example here, my vector starts at the origin. Vectors don't always have to start at the origin. So just keep that in mind. In this case it does, but it doesn't have to. Next we're going to use algebraic operations to learn more about vectors and to manipulate vectors. So let's say you're given vector u has component a1, b1, and vector v has component a2, b2. you could add those vectors. Now we know how to do it physically with a ruler and a protractor. We learned that yesterday, but today we're going to learn how to do that algebraically. And you can see what you would do to add two vectors is you take the x value or the horizontal component, add them together, and then you take the y value or the vertical component and add them together. And your resultant vector will be your answer from that operation. Same thing when you subtract. You subtract the a's and the b's. You subtract the horizontal components and the vertical components and you'll get your resultant vector. And then to do a scalar multiplication, you basically just distribute whatever your value is, your scalar, to each of the components. I think it will make more sense if we just do a couple, so let's go to the next slide. Notice we're given two vectors. Vector u has a component of 3, 6. Vector v has a component of -4, 1. The first thing we want to do is we want to add vector u plus vector v. So to show your work, what you would do is you would say u is 3, 6 plus v is -4, 1. And if I add those, I'm going to take 3 plus -4 and 6 plus 1. Simplifying, I would get -1 comma 7, and this would be your answer. That is the resultant vector, or the terminal point, at the end of vector u plus v. Let's try another one. Let's try part B. So part B, we want to do 3u. And so we're going to take 3 times u's component, which is 3, 6, and we're going to distribute. And so think of it as distribute here, distribute here. Your result is going to be 9, 18. This is going to be the terminal point, or the horizontal and vertical component at the terminal point of 3 vector u. Let's try part C. So we take 4 and then we plug in vector u, which is 3, 6, plus 2, and we plug in vector v, which is -4, 1. Distribute both of these scalars. When you do so, you get 12, 24, plus -8, 2. Now add. So it's just like PEMDAS, it's just like algebra. So now you're going to add your x values, or your horizontal components. And so 12 plus -8 is 4, and 24 plus 2 is 26. And so your final answer would be 4, 26. Now remember, part D, if we take the absolute value of u, this is like finding the magnitude. This is like finding what's the magnitude of your vector. And there's a formula for that. And so what you're going to have to do is you're going to have to take the square root of a squared plus b squared. It's like doing the Pythagorean theorem. You're trying to find out how long is that vector. What's its magnitude? You can see we're working with vector u. So if I go up to the top, I see vector u has a component of 3, 6. So down here, I'm going to say the square root of 3 squared plus 6 squared. 3 squared is 9, 6 squared is 36. Added together, I get 45. I want to simplify that. 9 goes into that, so I can rewrite it as root 9, root 5. The square root of 9, the reason I picked that is it's a perfect square. It's 3. And then because it's a magnitude, we do not want to have a negative. It will be positive. It's a distance. And so we don't have to worry about plus or minus. We can just say the magnitude of vector u is 3 root 5. Let's talk a little bit more about the horizontal and vertical components of a vector. Vector v is a vector with magnitude absolute value of v and direction theta. Let's draw that. So I'm just going to take a little time and sketch a vector over here. Let's say this is vector v right here. The magnitude of that vector is the absolute value of vector v. And This would be the horizontal component, I'll call that A, and this would be the vertical component, and they would be perpendicular to each other. And then it says we're working in direction theta, so let's just call this angle theta. That's the direction that that vector is going in. So let's say, just like here, I was given the magnitude and the direction of the vector, and I wanted to figure out what is the horizontal and vertical component, or in other words, kind of what's the coordinate at that end point or that terminal point. So think about your triangle. You have a right triangle. You can do a little SOHCAHTOA here. And so if you wanted to find out, well, what's the horizontal component? What's the length of A? What you're going to do is just basic SOHCAHTOA. You would look at your angle. Here's your angle, theta. You want to find A, and you know the magnitude. From theta, the A would be your adjacent side, and vector V would be the hypotenuse. So when you think about SOHCAHTOA, you would choose cosine. So if you did the cosine of theta equals A over V, and we would just show it like the absolute value of V, that's the magnitude, multiply both sides by the absolute value of V, or the magnitude of V. These would cancel out, and you can see the horizontal component, or A, is the magnitude of V times cosine theta. Now let's find the vertical component. So the vertical component is over here at B. And I would want to say from theta, that is opposite. I was given the magnitude, so I'm going to use opposite and hypotenuse this time to find the vertical component. Opposite and hypotenuse go with sine. So if I do the sine of theta equals opposite over hypotenuse, here's my equation. Multiply both sides by the magnitude of V. These cancel out, and you can see my vertical component is the magnitude of V times sine theta. And so these two little formulas will come in handy for finding the horizontal and vertical components of a vector. Or in other words, if I wanted to try to figure out what is the coordinate right here, or what is that component, it would be over A up B. So if I wanted to find that, I could use these formulas. Let's try one. Find the ordered pair. So theta is 48 degrees in the second quadrant, and the magnitude is 70. I always like to start by drawing out a sketch. So, remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4 on a coordinate plane. And so we're going to be 48 degrees into that quadrant. You always measure from the horizontal. So what I'm going to do is draw in right here. This is the 48 degrees from the horizontal. The magnitude is 70. 70 would go on the vector. Here's my horizontal component. Here's my vertical component. So keep in mind SOHCAHTOA, and let's see if we can find A and B. Let's start with A. So if I want to find A, this is adjacent to the 48 degree, and I'm going to use the 70, which is hypotenuse. Adjacent and hypotenuse go with cosine. So remember, cosine 48 equals adjacent A over hypotenuse 70. Multiply both sides by 70. You're going to have your calculator in degrees because our angle was given in degrees. And A is approximately 46.839. Now let's find the vertical component. The vertical component is B. B is opposite of the 48. I want to use the 70 again because I know that's right. In case my 46.839 is not right, I don't want to use that. I use the information that was given. And so in this case, we're going to do opposite and hypotenuse, which is part of sine. So I would go sine 48 equals b over 70. Multiply by 70, and then type that in your calculator. Make sure you're in degree mode because our angle is in degrees. And this turns out to be 52.020. And our final answer now is we want to write the ordered pair. It said find the ordered pair. So it would be, think about what quadrant you're in. A is actually to the left, so it's going to be negative 46.839 and positive 52.020. Because it's in quadrant 2, this point right here would have this as its component. Let's try another one. Find the ordered pair. Theta is 150 degrees. The magnitude is 120. So make a little sketch. 150 degrees, it doesn't say a certain quadrant we have to measure from. So 150 degrees is going to start over here and end up over in quadrant 2 somewhere. So let's say this is 150. And then our magnitude is 120. So the length of this is 120. And we want to figure out what's the coordinate or what's the ordered pair right there. Well, what I would do is make a right triangle. And in order to do that, you're going to drop down to the horizontal. Now, if we have 150 degrees on the right side there, this would have to be 30 degrees. Because you can see we're on the horizontal, and altogether that would have to be 180 degrees. So 180 minus 150 leaves us with 30. Let's call this A, our horizontal, and B, our vertical, and let's solve using SOHCAHTOA, or you could use the special right triangle 30, 60, 90 in this case. So I'm going to start with A. A is adjacent to our angle, and I'm going to use hypotenuse. So again, it's cosine of 30 equals A over 120. Multiply by 120, and then type it in your calculator. A is 103.923. Now I'm going to find B. B would be opposite of our angle. So opposite and hypotenuse is going to be sine. So sine of 30 equals B over 120. Multiply by 120, and then type that in your calculator. B is 60. And so now we write our ordered pair. So basically we're saying what's the coordinate at that spot. It's in the second quadrant, so our A value or our horizontal component will be negative. So it's negative 103.923, but our Y value or our vertical component, or B in this case, is positive, so 60. There's one more type of problem you'll run into on tonight's homework. It says find vector xy for which the given statement is true. 3, 5 plus xy equals negative 2, 8. So this comes down to just doing basic algebra. We're going to take the horizontal components, which in this case is 3x and negative 2, and make a little equation out of those. So it's 3 plus x equals negative 2. And then we're going to take the vertical components, or the 5, the y, and the 8. And 5 plus y equals 8. And it's as simple as just solving these. So we're going to go minus 3. X equals negative 5. And we'll go minus 5. Y equals 3. So the component that would make this statement true is negative 5, 3. Hopefully you feel like you can add and subtract vectors, multiply a vector by a constant, find the magnitude of a vector using that Pythagorean theorem, and find the horizontal and vertical components of a vector, basically using cosine and sine. Next, you guys are going to work on Unit 6, Practice 2 homework. And if you need help, let us know. Have a great day.